recording. Now it's recorded. So next week, Tuesday, during our class hour, during our class time, you will have your first exam. And during the exam, I will, you need to do the exam with my MATLAB. Just as I was assigning your homework, I will be assigning your exam. But exam will be active at 5 p.m. and you will not be able to access it after 7 p.m. So it will be time dependent. And you need to do it until 7 p.m. and after that you will have half an hour more to send me your written answers. So make sure that during these 2 hours when you are solving your exam, solve it on a paper in a nicely, because if you don't show all the integral steps, you will not get the full credit. Even though the My MATLAB is telling you you have the right answer, it doesn't matter. I will be checking your written answers and you will get the result according to your written answers. Okay. Again, next week, Tuesday, you will have your first exam and you will do the exam with My MATLAB and you will see the questions there. You will write it just as you were doing in like your homeworks. You will do the exam, but the only difference after the exam, 7 p.m., your exam is gonna be inactive. You will not be able to reach it, and after that, you need to send me back to your written answers. Okay. So whatever you wrote on a paper, question 1, just show all your calculations, all the integrals. You need to show how you solve them. So just writing the answer of an integral from some Googling is not going to help you. Okay, you will not get a credit from those questions. So you need to show step by step all integrals so that you can get the full credit. Okay. So you will have half an hour more and you need to send back to me your written answers with your name and with one file. So either PDF, you can scan your written answer, or you can take the photos of your answers and put it on a Word file with your name and send it to me. Okay. So from 5 to 7, your exam will be active, and until 7:30, you need to send your exam back to me. Okay. I will open from LMS. I will ask you to, put it to the LMS, your exams. It will be easier, I think. But you need to put your written answers. Okay. Do you have a question about the exam?
Teacher, our written answers will you mail or LMS?
LMS, I will make an LMS folder for you. Okay. Any other? And your exam is gonna be until lecture 5, at the end of lecture 5. So in LMS system, you know that you have your online lectures, and online lecture notes are also in the LMS. So you need to study lecture 1, 2, 3, 4, and 5 until the end of lecture 5. Do you have another question? Yes?
How many questions will be?
Actually, I didn't prepare it yet. I don't know, 8. I can say something like this.
Okay.
But you will have time, not so much time. You need to get practice to be able to finish on time. But you will have time to finish all of it. Okay?
We have 2 hours. Teacher.
Yes.
Yes. Thank you.
And half an hour more to send back to me the written answers. Can return 2 questions without done. During the exam you say that you can go to the other question and turn back to your previous question. Yeah, you can do that. You cannot do it during the homework? You can, right?
We can.
Okay, yeah, the same way. Another question? Okay, were you able to watch the online lesson, the previous one? It's an important one. It was about non-homogeneous case. I'm not sure if you watched it or not. I did not check it. But let me pass through it very quickly over that, okay? This subject is not going to be on the exam, but after that, of course, you will have it. Where was that? There you go. So, in last class, we talked about if we have non-homogeneous differential equation. You can see that, right? Tuesday, I had some problem on my laptop. I hope you can see it right now. Okay. And as you can see, this is second order differential equation. And there is this non-homogeneous part, which means that there is a term that is that depends on t, or that can be constant also. If you have that, you know that this is what we call non-homogeneous differential equation. And how we can solve it? We are solving it in two steps. In the first step, we need to solve the homogeneous part, just as we were doing in the last class. You know, we were writing the characteristic equation and we were finding the roots of this characteristic equation. And if we have distinct roots, we were writing these roots as the power of exponential. If we have repeated roots, one was coming just as it is as a power, and another one was multiplied with t times e to the rt. And if we have complex conjugate roots, we were writing as e to the alpha t cosine beta t and e to the alpha t sine beta t. You remember that, right? So just as this, our complementary solution is coming from this part, the homogeneous part. You need to solve it. You need to find the complementary solution from the homogeneous case, just as this is 0. After that, for the particular solution, we talked about two different methods. One was undetermined coefficient. And for the undetermined coefficient, we were using this table. Look at that. In this table, it says that if your right-hand side function is polynomial, then your solution is going to be in this form, t to the s times nth order polynomial. And in here, s is the multiplicity of 0 as a root of characteristic equation. So you will look at your characteristic equation, since you are finding the roots of it. You are going to be checking if 0 is a root or not. If it is a root once, your s is going to be 1. If it is coming as a root twice, s is going to be 2. So it cannot be more than 2 because you have, second order one. And for the second case, if your right-hand side also have some exponential function, then your solution form is going to be like that. T to the s, nth order polynomial, and e to the alpha t. Whatever e to the alpha t here, your solution will have the same e to the alpha t. And in here, s is the how many times alpha is coming as a root of characteristic equation. And if you have cosine or sine, also on your right-hand side, your solution is going to be t to the s, e to the alpha t, polynomial cosine beta t, polynomial sine beta t. You will be checking your solution in that form, okay? These are three different forms. If your right-hand side is polynomial, exponential, or sine and cosine, you can use undetermined coefficient. This is what we said. And here you go. This is one example. As you can see, the left-hand side is just the second order equation. And as a step 1, I need to solve this one just as the right-hand side is 0. 0 is the right-hand side. I wrote the characteristic equation, r squared minus r minus 2. I found the roots, two distinct roots, 2 and negative 1. And I just put them as the power of an exponential. That's it. This is the solution, complementary solution. And now I need to find the particular solution. Particular solution is about this non-homogeneous case, the right-hand side. So our g of t is 8 times e to the 3t. If you look at this one, it is like the second row. We have 8 times e to the 3t. So which means that our alpha is 3. Since P and T, the coefficient of exponential is 8, it is just A0 we have, as you can see. There is no T term, just a constant. So I said that my n is 0, since this is just a constant. My alpha is 3, because e to the 3t. And s is the multiplicity of 3. How many times 3 is coming as a root in the characteristic equation? Let's look at the characteristic equation and let's look at the roots. 1 is 2, 1 is negative 1. So there is no 3. That's why s is 0. If one of the root would be 3, then s would be 1. If both of them would be 3, then s would be 2. Okay? Just as I explained in here. So if my characteristic equation would be like that, which means that 3 is coming as a twice, then s would be 2. If my characteristic equation would be something like that, 3 would come once, then s would be 1. Okay? But since there is no 3 as a root in my characteristic equation, that's why I will assume s is 0. And I will check my solution in that form. T to the 0, A0, e to the 3t. Right? Just as like that, I will be looking my solution as A0, e to the 3t, because t to the 0 is 1. And I will take the derivative, first derivative, second derivative, and I need to plug them inside my original differential equation here. I need to plug in there second order derivative, first order derivative, and y itself, and I need to make it equal to the right hand side. And this ypt, this is what I'm doing. Second derivative, first derivative, 2yp should be equal to that one. So here the second derivative minus first derivative minus 2 times y itself should be equal to 8 e to the 3t. And from there you can solve a0 as 2 and you can plug it inside your particular solution. And as a step 3, you should say that my whole solution is complementary plus the particular. Complementary was coming from step 1, the homogeneous case, and this was coming from the non-homogeneous part. And after that, if you will have initial condition, you need to apply in here, you need to find C1 and C2. That's it, okay? I already explained this one in the video. I hope you watched that and I hope you understand it. If you have any question, you can ask to me right now. I just want to, skip over it. Do you have any question? No, I guess. Okay. And this is another example. As you can see, this is the second order differential equation, and right hand side this time is t squared. There is no exponential, there is no sine cosine. That's why it fits in the table to first row. It's just a t squared. So let's solve it then. First, as the first step, I need to find the homogeneous part. So I will write the characteristic equation, r squared minus 3r0. So two distinct roots, 0 and 3. And I will write my solution as e to the 0t, which is 1. That's why we have c1 plus c2 e to the 3t. Here you go. This part you already know it and you are responsible for the exam. And as a step 2, I will be checking g of t squared. And as you can see, this is second order polynomial. So my n is 2. And s is how many times 0 is coming as a root. So for the first part, if you have only polynomial, you are going to be always looking for 0. Look at that. Is there a 0 in here? As you can see, there is, right? It is 1s. So that's why I will assume s is 1. Then my particular solution should be in that form. I found S1 and I saw that my n is 2, so it will be second order polynomial here since my n is 2. I have a2t squared, a1t, a0. If I multiply t, I will get this one, my particular solution. Now I need to find what is a1, a2 and a0. To be able to do that, we need to take the necessary derivatives and we need to plug them inside my original differential equation, make it equal to t squared, and find a0, a1, a2. And exactly, I will take the derivatives, put it inside my differential equation, make it equal to t0, combine the terms, t squared term should be equal to 1 because there's 1 t squared here. T term should be 0, there is no t term here, and constant term should be 0 because there is no constant term. And from there, I can find a2, a1, a0, and I will plug in my particular solution. In here, I will plug in that, And my general solution will be the homogeneous case complementary solution plus the particular one that I just found. Okay. This is how we are using the undetermined coefficient. I hope it makes sense. And this is just another example. And in this example, I just show you the right-hand side can be sum of two functions that it can be applied for undetermined coefficients. As you can see, this is exponential, this is sine. And what you can do in here, your solution will be the complementary solution coming from the homogeneous case and the particular solution from the first function and second function. So you can solve it separately, these two, and you can add the solutions together. Okay. So from step 1, you know the deal. Write the characteristic equation, find the roots, write your homogeneous solution, which is going to be complementary one. And after that, look for 3e to the 2t. As you can see, n is 0. There is no t term as a coefficient. Alpha is 2 because the power of exponential is 2. And you will check if 2 is a root. No, then s is 0. Since s is 0, you will be looking the solution in that form. You will take the derivatives. You will inside your equation, make to 3e to the 2t, find the a0, and here you go. This is the particular solution from the exponential term. And now I will solve the same thing for 2 sine t right now. In here, you need to know what is S. S is how many times alpha plus e beta is coming. You know that. And alpha is exponential. There is no exponential, so 0. Beta is coefficient of t, 1. So if I is coming as a root or not. And since there is no I inside my root, so S is 0. Beta, which is the coefficient sine beta t of t, which is 1. And since there is no t term, the coefficient of sine t is just 2. That's why n 0. Alpha 0 because there is no exponential term. So you will check the solution as a sine t, b cosine t. Take the derivatives, put it inside your equation, make it equal to 2 sine t. You will find a and b, plug them inside your particular solution, and here you go. This is your general solution. This is coming from the homogeneous case. This is coming to first exponential term, non-homogeneous case, and this is from the sine cosine part. Okay. So you can find it like this with undetermined coefficients. But in this method, you need to have sine, cosine, exponential, and polynomial coming along for the right-hand side. Okay. And again, as I explained in the video, another method is variation of parameters. And this method is much more general case. If your right-hand side is not sine, cosine, exponential, or polynomial, anything, you can use variation of parameters. And to be able to use the variation of parameters, you need to assume your solution as the ones you have in the step 1. You will be using that. So you will assume your solution is u1, y1, u2, y2. And you need to find what is u1 function, what is u2 function. Okay, now I will show it in here. Firstly, again, you need to solve the homogeneous case just as the right-hand side is 0. Find the roots. Roots are plus or minus 2i. There is no real part, that's why there is no exponential. Your solutions are cosine 2t, sine 2t, right? The fundamental set of solution. And after that, you need to assume your solution is in that form. And what you need to do, take the necessary derivatives, put it inside the differential equation, make it equal to right-hand side. And once you do that, I will pass these calculations. You can check that out. At the end, you will see that your u1 and u2 is going to be coming as an integrals. And after that, you need to just sum them up like this. And what is these integrals here? So for the general case, you need to assume your particular solution is u1, y1, u2, y2. Y1 and y2 is coming from the first step. These are the solutions of the homogeneous part. And u1, u2 is, this is how you are finding. g of t is the right hand side times the second solution over the Wronskian y1, and u2 is, this time there is no negative, g of t, instead of y2 you have y1 over the Wronskian. And Wronskian, you know how to take it. Firstly, you need to write the, here you go, you need to write the solutions, take the derivatives, take the determinant, okay? This is the Wronskian determinant. We already saw how we were solving that. And for this question, again, step 1, write the characteristic equation, find the roots, repeated roots. That's why my y1 is e to the rt, my y2 is t times e to the rt. And since I know those, I can find the right-hand side, and I will assume my particular solution for the right-hand side is u1 times y1 e to the t, and u2 times y2, t times e to the t. And by using that, I will find what is u1, what is u2. u1 is minus g of t u2 over the Wronskian. And Wronskian, how we were finding? We are writing the solutions we found. What was that? E to the t, t times e to the t. And the derivative of e to the t is e to the t. Derivative of t times e to the t is t plus 1 e to the t. And for the determinant, multiply this diagonal minus the other diagonal. You will find Wronskian is e to the 2t. So in here, if you do the simplification, you will find u1 is the integral of this function. And in here, you can use the substitution method. You can assume 1 plus t squared is u. Du will be 2 dt du. Change of variables. Change it and solve your integral. And this is your u1. You don't have to use c1 and c2. And for u2, this time g of t, y1, Wronskian. Do the simplification. Here you go. This is your integral. This is arctangent t. So you found u1 function and u2 function. And now you know that your complementary solution from the homogeneous case was that. And for particular solution is u1 times y1 plus u2 times y2. Exactly. Here you can find the general solution. Okay? Is it clear? So Tuesday, I already explained this one to you with the video. Make sure that you watch it. And if you have question, can ask to me. Okay? And now today, I just want to also talk about reduction of order. And I want to finish the second order differential equations with that one. After that, I will also show some examples with you about the applications of the second order differential equations. And after that, we will be done with the second order one. We will talk about the nth order one. And after that, the Laplace ones. Okay? So let me show you. Here you go. The variation of parameters. Where was that? There you go. Sorry, reduction of order, variation of parameters. We already talked about it. I mean the reduction of order. Again, it is about. Here you go. Sorry, I had to. Was it that? Yeah, here you go. So reduction of order, again, order differential equation for any type. It doesn't matter if it is constant coefficient or not. What matters for reduction of order is you need to know one solution. If you know one solution, how can you find the other solution? Because you know that for the second order case, our fundamental set of solution forms with two solutions, y1 and y2. And if you know one of them, how can you find the other one? So this is very, similar what we have done actually. If you know one solution, the other solution, we are assuming some function v of t times the first solution. And we will take the derivatives just as variation of parameters, if you remember it. We will take the derivatives, we will plug them inside your original one, make it equal to 0, and you can find a second order differential equation. Once you find it, you need to do change of variables. You need to call v derivative u, then v second derivative will be u derivative. And That's why I will write y1 u derivative plus this plus v derivative is u. And as you can see, I just turn my second degree into the 1 degree. That's why we call it reduction of order. I reduce the order 2 into the 1. Okay. And for this first order differential equation, you already know it. We already did it in class 2. Okay. This is the idea. Let's look at it on an example. Look at there. You have second order differential equation, and these are not constant coefficient, but you know it, the t to the negative 1 is the solution of that one. If t to the negative 1 is the solution of this differential equation, let's use reduction of order to find the second solution. So the second solution, we are assuming some function times the first one. And I need to take the first and second derivatives of this trial form, and I need to plug them inside my differential equation. This is the idea. So since this depends on t, this depends on t, I need to use product rule. The derivative of the first function times the second minus first function times the derivative of the second. And now I need to take the second derivative. And again, I will use the product rule for this term and that term. So these two terms for the derivative of the first term, and these two terms are the derivative of the second term. And once I do that, I will find the first and second derivatives. I need to plug them inside this equation, 2t squared, y second derivative, I will plug in that. 3t times first derivative minus y equals 0. And in there, if you combine the terms and if you, multiply with 2t squared over the parentheses, and again do the simplifications, this is what you will get. See? Make sure that do these simplifications by yourself. You will get 2t v second derivative minus v derivative equals 0. And since there is a variable coefficient, you don't know how to solve it. But there is one way to solve it, which is reduce the. I will call v derivative 0, u. If v derivative is u, v second derivative will be u derivative, right? That's why I will write 2t u derivative minus u is 0. So instead of second order, now I have first order differential equation. And for this differential equation, if you write this one du dt by separable equation, you can easily solve that. So collect the u terms one side, collect the t terms other side, take the integral, ln u is 1 over 2 ln t plus c, then take the exponential, 1 over 2 is going to be coming 1 over 2 as a power of t in here. That's why you have u equals c t to the 1 over 2. If u is this, what you need is v, right? Then just, since v derivative is u, just take the integral of each side. The integral of t to the 1 over 2 is plus 1 over 3 over 2, which is going to be like this. Again, you don't have to use constant here. And this is your v function. So you found the v function. What was v function? Let's remember it. V function was the one that is defining my second solution. Because I assume my second solution is v times the first one, t to the negative 1. Then my second solution will be v times, v was here, t to the negative 1. V, I just found it. I will multiply with t to the negative 1. And here you go. This is going to be t to the 1 over 2. So if my first solution is t to the negative 1, my second solution will be t to the 1 over 2 according to the reduction of order method. Okay? Do you have a question? I hope you understand it. Look at that. This is going to be another example. I'm waiting a little bit for you. Yes. So let's look at that example then. Here you go. This is my second order differential equation. Again, variable coefficient. I don't know how to solve it, but I know that t square is satisfying this equation, which means that t square is the solution. Then how can we find the other one? Again, by reduction of order, I will assume the second solution is v times the first one. I will take the derivatives by using the product rule. And one more, I will plug in these derivatives inside my differential equation, make it equal to 0, and I will get this second order differential equation. But by reduction of order, I will assume u is v derivative, then I have t times u derivative plus u equals 0, and I will make this one as a standard form. And here you go. This is the linear equation. Your P of t is 1 over t. Let's remember it. Let's solve this one as a linear equation by integrating factor. And my integrating factor is e to the integral P of t dt, ln t and e is bringing, simplifying each other, we have t. Then I will multiply with t, and my left hand side will be always d dt mu times u. Mu is t times u. Integral of right hand side is 0. 0 times anything is 0 because. Then these are going to bring in each other. T times u is integral of 0 is just a constant. Then u is c1 over t. But u was v derivative. But I need is v. That's why I will take the integral of that one. This is c1 ln t. Then if my first solution is t squared, my second solution will be ln t times t squared. Okay? So it is not straightforward to guess your second solution. This brought you ln t. Okay, that can be anything. Do you have a question? This was reduction of order. I will not go further for this class. I want you to focus on the exam, get a good result from that, please. And I already assigned your homeworks. Your homeworks are a good example for you, and the examples I already solved in the class. Make sure that focus on them, solve by yourself. Don't use programs for integrals because you need to show all your steps for the exam, okay? Do you have a question? No question? Okay, then I will finish in here. If you will have a question, you can ask me. And sometimes you are asking me from the My Lab about your questions. So if your answer is so close to the right one, I can give your point back. It doesn't matter, okay? Once you send it to me, I will be correcting it. Okay? Okay, then see you on Tuesday during the exam.
See you, teacher.
See you, teacher.
Bye. Have a nice day. Have a nice weekend.